blind Altman plot. So in order to do the blind Altman plot, you should need two continuous variables, and usually we are doing this blind Altman plot to check the association between two variables. So you have to, it's like we have two methods for the same procedure, and you have to check whether these two methods meet the same criteria for that procedure. For that thing, we're using the blind Altman plot. So we are checking how much association is there between these two methods. So let's say I have taken one method and I have another method. So these are two methods and it is in continuous data. So next what I have to do is that in order to use the blind Altman plot, I have to check whether these two variables are differing from each other a lot or they are less differing. So if it is only less differing only, then only we can go for blind Altman plot. If it is less differing, what we can say is that these two methods are almost similar. So if these two methods are almost similar, then we can use either of these methods to our convenience. So that is what about blind Altman plot. So in order to do that, you have to first take the difference between these two methods. So you can see 20 minus 20 is 0. So like that, you have to take the difference, and you have to take the mean also, mean of these two. So each cell you have to take the mean. So 20 plus 20, that become 40, and it will be divided by 2 is 20. So we are taking average of each cell, each row we are taking the average, and each row we are taking the difference. That is the first step that should be done for a blind Altman plot if you need to construct a blind Altman plot. So you have to take the difference and you have to take the mean value. The next step is that we have to check whether this difference is significant or not. That is, we are using the one sample t-test, and we will compare it to the mean value of 0, and we will check whether it is significant or not. So one sample t-test, and you will use the difference, this column. So you can take the difference. So you will take difference as the test variable. Your test value will be 0, and you can click on OK. And your will be shown. So here our null hypothesis will be there is no significant difference between these two methods, and alternative will be there will be significant between these two methods. So if you want to continue with blind Altman plot, you should get, or you should have an evidence against the alternative hypothesis, or you should reject the alternative hypothesis. In order to reject the alternative hypothesis, you should have an insignificant p-value. So you can see here, this is my mean of the difference, this is my standard deviation, and here you can see the p-value. It is insignificant. Only if and only if it is insignificant, you can go for blind Altman plot. So what does this insignificant mean? It means that these two methods are almost similar. That's why we are going for blind Altman plot. So after you have a p-value which is insignificant, the next step is constructing a blind Altman plot to see the association between. To use that, you can go for graph, and in the graph you will have a scatter plot. So you can select simple scatter plot, and here you can give difference. You have to give difference on the y-axis and mean on the x-axis. So this is the way it should be represented. Difference should always be in the y-axis and mean should always be in the x-axis. So once you click OK, your scatter plot, here comes our scatter plot, and in the scatter plot we will construct our blind Altman plot. So in blind Altman plot, there are three variables that should be considered. First is the mean, that we have here already. So we have mean. Second is upper limit, and third is our lower limit. So we have to calculate our upper limit and as well as our lower limit. So to edit the chart, you have to click double left click, it should be given, and chart editor will be shown. So we have to calculate our mean value. So as you can see, the mean value is already presented. We have the mean value, that is minus 0.4. so you will have the mean value. So in order to make a line, you have an option here. So add a reference line to the y-axis. On clicking that, you can here, so you can take the position. So here it is 0.040. Okay, I'm going for 0.4. So on 0.4 the line is made. Next is my upper limit and lower limit. So it is calculated by a formula in which we will take the mean difference, which is our mean value, which is minus 0.04, and you have to take 1.96 into standard deviation. Why we are giving 1.96? Because this becomes a standardized normal curve, and as you can see 1.96 will give you 95 percentage of your data. So once you get 95 percentage of your data, all the 95 percentage of your data will be lying between these two limits. So you have to take the mean value and you have to calculate through plus 1.96 into standard deviation and minus 1.96 into standard deviation. So the standard deviation mean value is already calculated using the theta, so you have minus 0.4 as your mean value and standard deviation as 0.54, and if you calculate you will get the upper limit as 1.02. So I have to add a reference line at 1.02. That is my another reference line. As you can see on the y-axis I have only up to 1, so I have to make changes on that also. So you have to just double click on those limits, and just on the scale you can create let's say 1.5, and major increment also 0.5. I just need with 0.5, so all the scale will be changed. Now I can make the reference line of my upper limit. So already it was here, which was, it should be 1.02. so this will become my upper limit, and I have one lower limit which will be minus 1.10. so minus 1.10. so this becomes my lower limit. So here you can see this is the bland Altman plot. This is your mean value, this is your upper limit, this is your lower limit. For when you are giving in into a doc, or when you are representing it, you should give the mean value, you should give the labels also. For example, you have to give the mean value and how much it is, because we can't see from the scaling here on the y-axis, so you have to mention those also. So you can just give my mean is minus 0.04, and you can adjust according to your wish. So you can give here. Likewise you have to give for upper limit and also for lower limit, and everything can be, the chart editor can be done here. So when you double click you have all this. So if you give your chart editor according to your wish, you can change everything. So you can use all those things here. So if I need to fill the color as this one, so it would be looking a little more appropriate, it will be good for looking. So you can change all those here, all those variables, and how it should be look like, everything can be given here. So you have to give the mean value, upper limit and lower limit, likewise what I have shown. So insert a text box, you can have a text box, you can arrange all those, and once that is done, this is your bland Altman plot. So this is a typical bland Altman plot will be looking like. And after this we usually do a linear regression to see whether there is a proportional bias or not, and I will just show you that also. So in order to do that, you have to go for a linear regression. So in the linear regression, likewise your independent variable will be on the x-axis, that is your mean will be on the x-axis, which is our independent variable, and your dependent variable will be on the y-axis, which is our difference. So you have to make sure of that also. So difference on the dependent variable, and independent variable will be the x-axis, which is my mean. So when I click on regression, I can have the regression output, and you have to make sure the p-value is not statistically significant, or because here you can see the significant is 0.452, or you can see here also 0.452, which means it is not statistically significant and there is no proportional bias in my Bland-Altman plot. If there is proportional bias, then you have to take log transformation for all these variables. You have to compute log transformation for all these variables, and you have to do the difference and mean again and construct a Bland-Altman plot. So why we are taking the p-values and not significant? Because my hypothesis was there is no proportional bias, which means that my null hypothesis is there is no proportional bias, and alternative will be there will be proportional bias. And if it was a significant value, my p-value becomes significant, then it means that there would exist a proportional bias, so it can be come in my Bland-Altman plot. So that's why we are going for log transformation if the p-value is statistically significant. Now I will give you a one additional thing about in Bland-Altman plot. You can use the percentage error to check whether how much difference is there between those two methods. So here LOA means limit of agreement. So LOA can be calculated from our upper limit. So here my upper limit was I will just mention that also. So my upper limit was 1.02. So here, in order to calculate my LOA, so LOA, limit of agreement, which will be like upper limit minus my mean difference, that is the formula. So calculating the limit of agreement, so you will have here as upper limit equal to I'm sorry, minus my mean value, mean difference, okay, which will be upper limit was 1.02 minus my mean value was minus of, you have to make sure of this minus of 0.04. so actually it becomes plus, so you can see minus is plus, so you will have something around 1.02 plus 0.04, so it will be around 1.06. so LOA will be 1.06. and here the mean value is not the mean difference. Here the mean value is the mean of the two methods. So here you have method 1, here you have method 2. What you have to do is you have to create another cell of the average of these two, that is we have the mean, right? So this thing we have the mean, so this is the average of these two cells. You have to find the mean of the mean cell, so you have to find, you have to go for descriptive explore, you'll have mean. So I just need the mean value of this, so that mean will be 20.08. so here my mean value will be 20.08. now you can calculate the percentage error. So the percentage error will be LOA is 1.06 divided by 20.08 into 100, which will be around 5 point around 5 point, I think so. Let's calculate that. It will be around 5.3, around 5.3. okay, so this will be my percentage error. It usually says that it should be less than 30. So in order to have a good model, two methods, so here you have only 5.3 percentage error between these two methods. So these two methods there is only 5.3 percentage error, so it means that these two are a typical somewhat similar method, so I can use any of these alternative. So that's all about the bland Altman plot. So I think you have understood it very clearly about how to create a bland Altman plot and how to check the proportional bias. And first of all, you have to make sure it is not significant, then only you can go for bland Altman plot. Thank you for watching, and have a nice day. Bye.